Can you hear me? Hello? Hello, can you hear me? Okay, I'm guessing that you can hear me. All right, so dear all, thank you very much for participating in this webinar. Today, along with my colleague, we would like to provide you an introduction to the Ambient System company and tell you a little bit about the products that we would be presenting for you today. Let me start with a brief introduction of our company, who we are, what we are doing, and what is our history. And later on, my colleague Daniel will continue with topic of the product introduction itself. So I'm hoping that you're seeing the screen. So let me go with the introduction step by step. Okay, so we as an ambient system company has been founded more than 30 years ago. We started as a specialist in fire and security system, and later on started to develop our own voice alarm systems, which we are manufacturing over those years and have a full control over the process itself. During the period, we managed to gather more than 5,000 commissioned projects here in Poland, but also in European Union, South Asia, Middle East. Till today, we are focusing on providing innovation, high-quality products, and of course, professional support along with that. Our backbone and key products are public address, voice alarm system that are fully EN 5416 and EN 5424 certified. Recently, we also started to develop another, let's say, leg of business, and we are presenting intercom and integrated solutions. Our headquarters is located in Gdańsk, in north of Poland, where we've got under our own control R&D department, the complete product management, and whole of the manufacturing process, along with quality control and all necessary testing facilities in order to provide certified solutions that I mentioned. This quite distinguishes us in comparison to other manufacturers which do not have such a control in-home. The core business of ours is related to the markets where we can provide EN54 type of solutions. So we are talking here about all of the type of public buildings, hotels, or accommodation type of investments, offices. We are also very strong in transport sector with vast portfolio of the airports, train stations, and metro projects all over the world. One of also the parts of our business is industry, where we can provide to you ATEX certified speakers if required. This is maybe not a major part of our business, but I just wanted to underline that we are also capable of providing solution for such. As I mentioned, during that period of time, we gathered quite vast portfolio of projects, along with transport, hotels, like Hilton, for example, but also recently delivered the Żeleznica Tunnel, where we provided more than 50 specialized horn speakers, vast amount of airports, railway stations, metro stations, Stadiums, for example, recently also delivered Osijek Stadium in Croatia, along with maybe long-distance investments in Lebanon and Eurofighter base in Kuwait. The product itself is not also one of the values that we are providing for our customers. We are also delivering quite vast range of pre-sales and post-sales support, starting from concept design, proof of concepts, acoustic sound studies, but also will be daily work, I would say. Quotation and system optimizations. We are also sharing the knowledge with our partners. Therefore, we are providing monthly based training and webinars. And if it go for that post sales, we are also able to provide you rack assembly, so complete solution delivered to the investment, along with factory acceptance test if required, and of course engineers on site support if such a request is also important from your point of view and for your customers. That would be a short introduction to our company history. Let me now try to give the voice to my colleague Daniel, who will be able to provide you a little bit more insight on the products itself. So just give us a second to switch the stand and we will be good to go.
Good morning, everyone. I hope you all can hear me. Does everybody hear me? Please let me know on the chat. Yes, thank you. Let me introduce myself. My name is Daniel Dams. I'm a senior support engineer at Ambient System, and I would like to introduce you to the idea of the PAVA, which stands for Public Address Voice Alarm, and let you know about some technical details of the solution itself. Why do we use it, and what are the methods for designing, and how we can implement specific products to fulfill the idea of the PAVA system. First, I would ask if anyone from you guys have experience with voice alarm installations. Let me know in the chat. So experience with either designing or commissioning, programming. Did you ever have any experiences with voice alarm so far? Okay, so no, I guess this is a new topic for most of you. So the PAVA systems, PAVA stands for Public Address and Voice Alarm. the main principle of the voice alarm system, of the PAVA, which is public address and voice alarm, is to deliver sound, audio signal to the people which are present in the building. And the purposes can be many different purposes. And that's why we make the distinction between PA and VA. So PA, this is the public address. This is the general purpose audio system for delivering audio messages throughout the building for general kind of purpose, which is general announcements, intercom functionalities, informing people about some events in the office building, informing customers in the shop about some current events, for instance, about some trouble on the parking lot when there is a car blocking a parking lot, or for advertising, or simply for music broadcast, like in a hotel or in the shopping mall. So these are the public address functionalities, and deriving from that, we can point out that there are special systems, special audio systems for buildings that are which purpose is mainly to send audio signals for emergency purpose. So in case of a dangerous situation, such as fire or bomb alarm or another disaster, for example, earthquake or any kind of special situation where people and assets can be in danger because of the situation that is dynamically changing, such as fire. The voice alarm system is the kind of public address system that can deliver the message in an automated way, organized way, to the different zones in the building. And the main purpose is to save lives of people who are in the building in the face of danger. Now, as you can see on this picture, one of the most common scenarios where we use public address voice alarm system is the voice alarm system which is coupled with the fire detection system. So here on the left side here, we've got a building that has a fire alarm system. Well, it's the same building on the left and the right side, but on the left side we can see the fire detectors, and on the right side we can see the voice alarm system endpoints, which are the loudspeakers. And in principle, in this kind of situation, which is the most common scenario for using the voice alarm system, is coupling it with the fire detection system, so that we can, in the situation where we've got a fire detected, for example, here in this zone, the signal from the fire detector goes to the main fire alarm system that's somewhere in the basement, probably, and that will be transferred to the voice alarm system, the information about the detected event, and then the voice alarm system sends signal to the loudspeakers in the same zone where the fire has occurred, right? So this is the main working loop of the fire detection system and voice alarm system coupled together. This is the most common scenario, fire detection. Now, since the fire detection system has usually multiple zones, designed multiple different zones, For example, this area, each floor is a different zone, and so on. And at the same time, the staircase is also a separate zone. In the voice alarm system, we organize the groups of speakers in the exact same way as we designed the different areas that the fire exactly divided in zones like the voice alarm system. Now, good question is, in this situation, why do we need that? Because the fire detection system very often have sirens, sounders, and other alarm devices that can be used, that are used to inform people about the danger, that the danger has been detected. Now, the multiple studies has been done, and there is a very clear correlation between the efficiency of evacuating people from the building, and the kind of signal that we are sending to them. So, as you can see on this little chart, these figures are based on multiple studies. Only 13% of people in the building react to simple sounders. Yes. So the sounder is the basic sounding device that is normally coupled with the fire detection system. It's only beeping or making a siren sound. And only 30% of the occupants in the building are reacting to that. Why is that? Well, that's even less than 30. This chart is showing like 25%. So they don't understand the signal from the fire detection system when the sounder goes off. It's simply many times it is misunderstood. So people either don't know what it means or misinterpret. The signal is misinterpreted in such a way that people simply ignore it. And there are also people who know what that sound can mean, but they ignore it anyway because they might think, for instance, that it's a drill or it's not a serious situation. And that's why so few people react to the sounder signal. Now, we have slightly better efficiency evacuating people from the building when we give them text information. And text information is, for instance, a instruction that is given to the people in the building to show them evacuation plan. Now, the problem with this is that not many people read the evacuation plans in the buildings, especially in the buildings where they are very short, limited time, like, for example, shopping mall or a movie theater. And the studies have shown clearly that on average, 75% of people react to the voice messages. So if we set up a system that is sending voice messages in the building to the people, telling them the precise instructions, explaining what is the situation, what the kind of danger is detected, people are much more keen to listen, to understand what the situation is, to keep calm, and to react accordingly. So this is why the voice alarm system is so important part in the buildings where many people are at the same time, and they are not familiar with the shortest evacuation way. On the next slide, here you can see the exact, the timeline of the typical fire event. Yes. So that this is the typical timeline of the events, how the situation develops when the fire is detected. So first we've got the event occurs. The event occurs, there's a fire, and before the fire expands so that there's smoke or heat to the point where the detector can react, here we've got the detection point. There's always some delay time introduced because sometimes the detection can be fake detection. For example, there's somebody went to the toilet to get smoke and to smoke a cigarette and triggers a fake alarm. This is not a situation where we want to evacuate people. So usually in the evacuation plan, there is some time introduced between the detection and start of alarm to confirm or to clear the alarm when it is introduced in as a sabotage, or for example with smoking a cigarette somewhere in the building. Usually there is a person in big buildings. There are always persons, people responsible for the safety and security in the building, and they are usually managing the fire detection system in such events, so that they have a procedure they have to follow. And then if there is no reaction to clear the alarm, to clear the detection, then the alarm goes automatically off. And this is where it all starts. This is the point where we start to hear the messages being spread out throughout the building, from the speakers or from the sounders. And you can see here the reaction time on the sounders in the fire detection system. So the reaction time is much, much longer than in case of a voice alarm system. So that's why we use voice alarm system as compared to the fire detection system with sounders, because it simply takes less time for people to react and to leave the building and to escape the danger. Where do we use the voice alarm systems? So there are main groups of the voice alarm systems that are widely used in the main areas of the business that we are doing. So that is Europe, Middle East, India, Southeast Asia, and many countries throughout the world that have introduced voice alarm standards. And depending on the country, it slightly differs, but mainly the voice alarm system is required in the large buildings where general public is present in big numbers for extended periods of time, such as offices, schools, shopping malls, universities, transportation facilities such as airports, railways, stations, and places where people are present also overnight. That is all kinds of accommodation facilities, hotels, hospitals, dorm houses for students, student houses, care homes for elderly people. So everywhere where quite a large number of people is present at the same time for an extended period of time, or where people are present even in for short periods of time, but they don't know the evacuation plan, such as in the shopping mall. Everywhere in such kind of premises, it is required to have a voice alarm system. Now, how does the voice alarm system look like in terms of components? So I'm going to explain this. This is a block diagram of a typical 3-floor building, kind of office building or a shopping mall, where we could use a voice alarm system. So here we've got the fire alarm system. Yes, so this is the source of the signals to trigger the alarm. Fire alarm system with the detectors throughout the building. Now, when a danger is detected by the fire alarm system, then the signal is sent to the voice alarm system. Here in this case, we've got 2 locations in the building. One location is on the ground floor, where we have the main voice evacuation panel. And here we've got another evacuation panel that is in a different place in the building. In this case, we've got 2 locations for voice alarm system. And the voice alarm system here is connected by means of fiber optic ring. So we've got a transparent network of the voice alarm panels. And this is the main core of the voice alarm. Yes, location 2, location 1. Now, as you can see, there are loudspeaker lines that are feeding different zones. So here we've got one zone, another zone to the loudspeakers. Yes. And so on and so on. So these cables are spread throughout the building to deliver the message to deliver the audio signal to the speakers. Also here we got staircases, usually the single staircase, because it's an open space, open common space, it's a separate area, separate zone for evacuating. So this is the main core of the voice alarm system, the central panel that is detecting the signals from the fire detection system, and it's sending audio signals to the speakers here and here. Now, the second location, for example, we could imagine that there is the 4th floor here, that we have 4th floor and 5th floor and so on, and we can have over here other speaker zones, another zone, and yet another zone. So the voice alarm systems can be distributed over the building to deliver the audio signal in an effective way over the network. Voice alarm systems also consist of fire microphones, and these microphone devices can be used for public announcements or for evacuation messages by the fire department. The usual scenario is that in the typical voice alarm system, we've got some microphones that are used for the general purpose. For example, this one here. Excuse me. This microphone here is a general purpose microphone that can be used for announcements and advertisements and some general messages to the people in the building. And this microphone over here with the 5th microphone can be used as a fire microphone for the fire brigade when they come in case of the major fire event. Yes. So this microphone will be used for live announcements for the fire brigade when the fire brigade comes in case of the fire. So, okay, so we have covered the components of the system. Now, we will quickly talk about the standards that are giving us guidelines for designing of the voice alarm systems. how do we even approach how to design a voice alarm system? So you can take a look, you can take notes or screenshots about these standards. These standards are the typical code of practice for designing and planning a voice alarm system. If you need more details, you can always look at these standards, or you can consult Ambient System. We've got quite a lot of experience, and we always apply these standards for our installations. Also, when it comes for the products, there are separate standards that give very hard requirements for the equipment itself. It's also important to take a look at whether the equipment, the voice alarm equipment that you are planning to use, is certified or not, because only certified equipment is approved and allowed to be installed in the buildings of interest. And in the moment, I will talk about some of the most important details in planning and designing of the voice alarm system. How do we even approach? How do we start? What to think about when we begin to design a voice alarm system. So these are the standards that I will talk about, some details from these standards. And here we have mentioned the product approval standards. So these three standards, from the group EN54. The group EN54 of European standards are describing the requirements for the fire detection and fire alarm systems in general. So part 16, part 24, and part 4 are the most important approvals for the products in the voice alarm systems. So if you are designing a voice alarm installation, you need to make sure that the products that you are applying for your design are certified, have actual certificate of compliance with these standards. This one is for the central equipment, this one is for the loudspeakers, and this is for the power supply. Yes, so please keep in mind that always compliance and the certificate with these standards is very important to have the official approval of your voice alarm system. Now we will also speak a little bit about one detail that is super important when it comes to the approval of the final commissioning of the system when it's already installed in the building. And that is the standard that defines a parameter called speech intelligibility. Speech intelligibility is defined by speech transmission index, or other words, STI. And the STI is one of the most important parameters, output parameters of the voice alarm system after it's commissioned and installed. Yes. Okay. Now, one moment. Okay. So when it comes to the commissioning of the system, we need to make sure that the system performs as expected, as required by the standards. What does that mean, that it performs properly? Well, the main parameters of the sound system in the building for emergency purpose, which is the voice alarm, are two parameters. One parameter is the sound pressure level, or SPL. That is the level of the audio signal that can be heard by the people inside the building. So we need to make sure that the voice alarm system is covering all public areas where people can be present, and that the level of the audio signal, that the sound is loud enough for all people to hear it, and so that nobody is left out in the emergency situation. So we need to make sure that all areas are properly covered with sound with a minimum loudness, yes, of the sound. So there are absolute minimum levels that are required in voice alarm planning. Also, we need to make sure that the sound that the voice alarm system is producing is louder than certain minimum above the noise, because there are some installations in the buildings where the noise is present, factories or shopping malls or train stations. There's always noise in the background, so we need to make sure that the emergency system is louder than the noise, much louder. And we also need to limit our maximum level so that we are not making any danger to the people in the building with too high levels. Yes. So the voice alarm system needs to be designed and adjusted so that the audio levels are above the noise. If there is not much noise, then there are at least these numbers, 60 dB or 70 dB, 75 dB. And we need to make sure that it's not too loud in case of high noise levels. The second parameter that is of the same or even bigger importance than the SPL is the STI. That stands for the speech transmission index. The speech transmission index describes in the scale from 0 to 1 the quality of the speech signal. 0 means that we can't understand anything, and 1 is when we can understand 100% everything that is being transmitted from the speakers. In the real life, there's always somewhere between 0 and 1. And we need to make sure that that the speech signal coming through the speakers is higher than the 0.5 STI. How are these parameters measured? Well, there are many instruments on the market that the audio specialists and sound engineers use in their daily work. So sound analyzers, including the STI meters. So these parameters can be measured with measurement instruments in the building after the system is installed, and depending on the results, we can adjust the parameters of the system so that we can improve the sound levels or the STI. Now, we've got two methods for designing the loudspeaker distribution, the layout of the loudspeakers in the building. One method is the prescriptive method. This is the fast method. And then we have detailed method. And detailed method is based on the specialized acoustic simulation. So we can simulate the behavior of the voice alarm system in the building by means of the computer simulation. Now, when we focus on the prescriptive method, as the simplified method, we can make a design of the loudspeakers in the building based simply on the parameters of the loudspeakers from the technical specs of the speaker. So when we know the covering angle of the loudspeaker, because each loudspeaker has certain angle where the sound is being transmitted. Yes. When we know the sensitivity of the speaker, which means that how loud the speaker is 1 meter away, here 1 meter away from the speaker, when it's powered with a 1 watt power. These parameters are specified in the technical specification of each speaker. When we know the loudspeaker type, so that means that the covering angle is defined and the sensitivity. And when we know what result we want to have here on the listening area in the building, then we can define how many speakers we need to provide to cover the area. So for example, I will draw a cube here that is showing a space in the building. Let's say this is a room, and this here is floor, and this is ceiling here. Yes, and what we want to make sure about is that on the listening area here, 1.5 meter, that is usually the average, 1.5 meter above the floor, that we've got the best possible coverage with audio signal. We need to make sure that our speaker, for example, there is the speaker designed in the ceiling, is covering this area here without gaps with a required SPL. So this is the sound coming out of the speaker, yes, and that on this area here, the ceiling speaker is covering and gives our required SPL. Apart from that, frequency response of the speaker is important, and ambient noise that is in the background. Why ambient noise? Because when there is a noise in the building, we need to make sure that the sound level from the speaker is louder than the noise. So this is how the prescriptive method is used in the areas, in simple areas, offices, hotel rooms, general areas of where the space is not very demanding in terms of acoustics. So open spaces in the office areas, all small kind of spaces like toilets, bathrooms, hotel rooms, hospital rooms, corridors, all these areas can be, with big success, designed with the prescriptive method. Now, when we have more difficult acoustic situation, where we have very large open space with very difficult, acoustically difficult materials that are producing a lot of reverberation time, we can adapt acoustic simulation to prove that our design of the loudspeaker layout is delivering the required level. So on this building, for example, in this picture, for example, you can see over here an open space in the office area without acoustic adaptation, where the materials are very difficult: glass, tiles, concrete, giving a lot of reflection to the sound, and the STI, the average STI, is very low. Yes. And when we have improved our building with the acoustic adaptation, we can improve the STI to a much higher parameter. Yes, and this we can prove how our speaker system is performing in certain area based on the very accurate acoustic simulation. Let's go very quickly through the loudspeakers that Ambient System is offering, because the loudspeakers, depending on the purpose, you would be using different loudspeakers. Of course, all speakers are available in our product catalog. You can always refer to our catalog to see what kind of speakers you can use and to which areas they are designed. But I will speak very shortly about the speakers, and we'll go very quickly to the products that Ambient is offering in terms of voice alarm solutions. So the typical loudspeaker for the voice alarm must be built in a certain specific way, so that usually there is a driver, a low impedance driver, with impedance matching transformer. The transformers in the voice alarm system speakers are very widely used. This is the most common way of how the voice alarm speaker is built. There is a transformer inside, because the voice alarm speaker lines are usually operating with this voltage. Basically, all voice alarm systems in Europe, as well as in States and all Europe, Middle East, Southeast Asia, India, are operating with a 100-volt line. What does that mean? That when we have a voice alarm system and the speaker, the voltage here on the line is different than the voltage on the speaker cable, for example, at your home, what you have at home, from the between amplifier and the loudspeaker. So here we are using a higher voltage. We call it 100-volt line, or a constant voltage line. And why do we do this? That is because in the voice alarm installation, we have usually a large number of speakers. And these speakers must be connected, in many cases, to the same line. Now, if we do this with our home theater speakers, we will overload the amplifier very quickly. That's why the 100-volt technique has been introduced to voice alarm and public address, to be able to drive multiple speakers connected in parallel to one cable. Yes, we are just stepping up the voltage to be able to deliver the same power with less losses on the cable and with less influence on the amplifier load. So this is the way the voice alarm systems are operating on the speaker cable. Now, what kind of speakers do we use in voice alarm? Usually, these are the main loudspeaker types that we use. Flush mount ceiling speaker. This is the speaker that goes usually in the ceiling when we have a ceiling, or for example, plasterboard. And we make a cutout for a speaker, and we install the loudspeaker like this in the ceiling, so that it sits inside the ceiling. Here's a cable that comes in, and it's producing sound downwards toward the floor. That is the typical way where we have hanging ceilings, fake ceilings in the building, such as in hotels or offices. The other most commonly used speaker is the wall-mounted speaker. And we have a wall-mounted speaker. Obviously, we mount the speaker on the wall so that it can produce sound this way to the general public in the building. And this is also a very convenient way of delivering audio in areas where, for example, the ceiling is very high. Different types of speakers. These types of speakers are usually used in outside areas, like parking lots and areas where we have very high temperature differences, humidity, external weather conditions. So horn speakers, not the best sound quality, but very efficient, very loud, and very weatherproof. You can usually use these kind of speakers as well as projector speakers in the areas where you need to deliver the audio, the sound on a larger distance, many times outside, in the outside conditions, outdoors. Also column speakers. Column speaker is very interesting speaker because you can use it. It has a very nice looking design. You can use it in areas where aesthetics is very important. But also a loudspeaker like this has a better sound projection in the distance. So if you compare, for example, this loudspeaker and this loudspeaker, if you compare it, the way it produces sound, I will draw you. This is a column speaker, and this is the projector speaker. The projector speaker has usually wider coverage angle, like this, and the column speaker has usually narrow coverage angle, like this. That means we can. That also translates into that the maximum distance that the speaker can cover. So the projector speaker can, for instance, cover the distance up to, let's say, 20 meters. And the column speaker will project the sound much longer with the same level. I would say you can even double this. So up to 40 meters in this case. You can have a very good sound coverage. This is a slide showing you how we design speaker lines. This is a typical hotel floor. The way that we design is AB, so-called AB installation. This is in case it's designed in a redundant way, so that if we lose one of these loudspeaker lines, for example, this one, so the line B is still operational and giving sound to the required areas. Yes, if this line is broken, so all these speakers are dead, there's no sound coming out, then at least line B is still working. In voice alarm systems, there are many elements that are redundant or secured in such a way that if we lose some part of the system, then the rest is still working. Here we've got an layout of the office area, of the ceiling speakers. Here we've got another layout of the horn speakers in the underground car park. You can see that the horn speakers are pointing the same direction, and this is to make the sound the audio signal, the acoustic signal coherent, going to the same direction. Yes. Here we've got another example with staircase. You can see every floor must be covered with sound, so that there is no gaps in the whole, in the entire space. Well, including this also here. So the speaker will be also projecting the sound over here and here, so that all the areas where people can evacuate should be covered. Let's take a look now very quickly about on the products that Ambient is offering in terms of central equipment. This is the core part of the voice alarm. So we've got three major kinds of central equipment: mini system, MIDI, and multi-VES. Mini and MIDI are, as the name suggests, designed for small and medium installations. Especially mini VES is designed in such a way that it's contained in one housing, and it only requires the cables to be connected from the field, like the speaker cables and the cables connecting to the fire detection here to these terminals. The system is all in one, so it includes all components. It is pre-designed already, and it has a closed architecture. There is no modular elements in it, making it very easy for installers and commissioning engineers to implement in the building. And a single system like this can handle up to 640 watt of loudspeakers, and deliver up to 2 messages at the same time to different areas. Like if you remember the picture with the fire detection system with many different zones, so that you can transmit 2 different messages into 2 different zones at the same time. And a single box like this, mini-VES, can handle up to 16 loudspeaker lines. 16 loudspeaker lines. That is, in many cases, that is enough. 640 watt and 16 lines that is small installations. That is more than enough to cover a large portion of the market with the voice alarm design, such as shopping, shops, small hotels, and office buildings. And if that is not enough, you can always connect a network of many mini systems and make a single system out of them to cover higher areas. Here we have a very quick look at the connectors. The system comes with all the connectors needed and with instruction. And the system, just to let you know about the network connection, the network is TCP/IP based. So you can run over the local area network with all ambient products. You can run them over the TCP/IP network in your building. So you don't need to build a special extra network separated from other networks. Although it is recommended to make a separate, at least VLAN, or even a separate local area network. But this you can design very easily. You can define a separate part of your network by defining infrastructure cables in the building that are responsible only for voice alarm system. But the integration is very simple by TCP/IP. Here we have a very quick overview of the mini-VES. It comes in different versions, depending on how many zones you need. So 2 zones, 4 zones, or even 8 zones, serving 4, 8, or 16 loudspeaker lines. And the difference is in the number of loudspeaker outputs, and the main difference is in the amount of power that can be delivered from the mini-VES to the speakers. Otherwise, the systems are very similar. MIDI-VES. MIDI-VES is slightly larger than mini-VES. Not larger in terms of size. In terms of size, it is exactly the same size as a mini system, but it is larger in terms of the specifications. This system can handle single cabinet can handle maximum 32 lines and 3000 watts. Yes, and it can deliver much more messages at the same time, so it can deliver up to 6 compared to 2. And mini-VES, this is the most important difference, the bigger power that it can deliver. If you look back at the mini-VES maximum power was 640 watts. Yes, whereas mini-VES can deliver up to 3000. connection bay is practically the same, and also the network ports are based on the same architecture. The system is always equipped with network card. The network can be either copper, Cat5 or Cat6, or even higher, or fiber optic. So the system has already fiber optic network card built in. Here are some specifications of the MIDI-VES. Again, all these numbers you can find on our website, and you can see, compare what the differences are. It is not that very exciting, except for the fact that the MIDI-VES comes in two versions, 8 zones of 16 zones, that is 16 lines or 32 lines. If you remember, one zone is usually 2 lines, A and B, from the drawing of the speakers, yeah, A-B speakers. That's why the difference is between speaker lines and zones. So 16 lines and 32 lines, and the difference is in the total audio power delivered to the system. So we've got the smaller one with 16 lines, it's 1,500 watts in total, and the bigger one is 3,000 watts. And the largest system that Ambient is producing is Multi-VES. Multi-VES is built slightly different than the MIDI and Mini. MIDI and Mini, as you remember, they're all in one box, ready. Everything is ready-made and ready to connect to the cables in the building, whereas the Multi-VES is it's a huge machine. It's a flagship of voice alarm systems from Ambient, and it is much more capable. It can deliver much higher powers and can serve much larger installations. And therefore, it is built in a modular way. So there are different modules, different components in the Multi-VES system. Let me show you what this is. These are the control units. Control units. This is the main. This is the first and second control unit in this case. That are the brain of the system. Power amplifiers, where they are connected inside, obviously. And here's the power supply manager with the power supplies and batteries. Yes. So here's the backup power supply equipment. Power supply with battery. And which components do we use in the Multi-VES? Well, there are many components. Like I told you, the brain of the system is the control unit. Then we've got the amplifiers that receive the signal from the main controller, and they deliver the signal through the controller again. I will tell you in a moment, to the loudspeakers. And why do we need that loop here? That we first go over here and then we go back from the main amplifier to the control unit. It is the surveillance, because the control unit is monitoring over here. There is always a measurement of the output of the amplifiers, so that the control unit can detect in situation where the amplifier is failing, that there is no sound, so it can use another amplifier, a spare backup amplifier, to deliver the sound to the speakers, in case if one of the amplifiers is gone, yeah, because the failures can happen. So this is the main part of the system, the control unit and the amplifiers. And obviously we've got a power supply equipment. The power supply equipment is responsible for taking the power from the mains and delivering the DC to the system this way in a safe way to distribute the power over different components in the system. So, so that if you can see over here, we got our power supply system over here, and the power is distributed inside the rack to different components. In case of mains power failure, the batteries are responsible for delivering the power to the rest of the system. And usually the batteries must be designed to deliver 24-hour standby and either 30 minutes or 60 minutes full power after the standby. This is the backup battery is designed in the voice alarm system so that in case of the power failure, the system is still able to maintain its own power supply and deliver the audio message in case of emergency. And of course, very important part of the voice alarm system are the microphones. And the microphones can be, the ambient microphones are in 3 different types. The general microphone with buttons. Over here we have push buttons. The general microphone with the touch screen, where you have much more information and more zones on one screen. And a fireman microphone that is used only for evacuation purposes. It has much more sturdy design and is used. There's usually the distinction. This is for commercial purpose, and this is for emergency purpose. Okay, very well. So these were the main components of the voice alarm systems that the Ambient is making: multi-VES, midi-VES, and mini-VES. I hope you can look at the catalog of the Ambient system. I will simply just go back to one slide. I will show you just one more slide that you've seen already. Just to remind you about how these things are connected together. So if we go and look at the diagram again, fire alarm system. I purposefully came back to this diagram because we looked at the products, and now we can see exactly what it means. So we have again fire alarm system that is delivering the detection signals, and here we've got one voice alarm system, for example, multi-VES, multi-VES, that is the big system with modular architecture. And here in another technical room in the building, we can have, for example, mini-VES. Yes, and all systems made by Ambient are with the network card able to cooperate together in one network and managed as a single system. So this is also a beauty of products from Ambient, that they are all cross-compatible together, and they make one common platform for voice alarm solutions, from small installations up to even very big installations where you have multiple panels. I believe the biggest installation of Ambient equipment that I've seen so far is the network of over 40 panels connected together in one network. Yes. So these are the main panels, and we've got also the microphones. So here, one microphone, microphone 2, microphone 3, microphone 4, which are connected to our system. You can see, these microphones can be connected directly to one of the systems, but this microphone can be connected also in the ring network. If we want to save some cables, we can always go either daisy chain or in the ring topology with our microphones. So, yeah. Okay. Just to close we will be closing the presentation very soon. I want to talk about one more detail about something that can connect all these solutions in the building together with the building management system, BMS, and fire detection system, and also other audio systems in the building, like intercom systems. It's something that Ambient System designed as a common platform for communicating all these audio installations in one common system is the SCP, the Security Communication Platform. And Security Communication Platform by Ambient System is consisting of three major components. So the first component is what we just spoke about, the PAVA system. Yes, PAVA system. Now, what Ambient is also offering together with the PAVA systems as a complementary equipment is the control and visualization software we call Yellow. And Yellow is basically a control panel on the computer, on the touch screen, to be able to operate the voice alarm system in a very convenient way, in a very attractive, visually attractive way. And as a third component, this triad of SCP is this SIP intercom systems that also, we will not focus on the SIP intercom systems that Ambient is offering. You can always take a look at our website or in our catalog to see what devices in the intercom area we can deliver. But the SIP intercom is also part of the SCP architecture. So we can design one system that is connecting all these three in one architecture with one general graphical interface here in this software, so that we can communicate also between intercom system and PAVA system bidirectionally. How it's connected, how these three parts can be connected together with so intercom systems, SIP components such as SIP speakers and voice over IP phones and intercom stations, as well as the Yellow software for visualization. It goes over the TCP/IP network, obviously. It can be connected within one LAN, or if we can create a VLAN throughout, if we can make a tunnel between different locations and create a VLAN between different buildings, we can even connect multiple buildings in one platform that is managed from one place. And again, components, voice alarm system, yes, including microphones. The SIP system that is consists of the intercom stations and the loudspeakers. We got another portfolio of loudspeakers that can connect directly to the TCP/IP network over LAN cable, Ethernet, with power over Ethernet. So we can deliver sound to less demanding areas where we don't need voice alarm, but for convenience we can use the SIP speakers. And the third component of the triad is the Yellow software for visualization. Yellow software is a very attractive, visually good-looking software. It is optimized for touchscreens. and it gives you full control panel over the voice alarm. So you can look all the events in the history, you can trigger a message, you can start any event, trigger an input, trigger any output in the system, in your voice alarm system, here from the touchscreen on the Windows PC. Gives you very comprehensive, a very comprehensive interface where you can use, for example, your floor plans or your logo of your company to make a very attractive, state-of-the-art, let's say, a big screen control panel. It's not mandatory, but many companies, many customers are very happy to have a good-looking interface for the security personnel, so that even without special training, people can operate the public address system in the building and make the maximum use of it. Because, as the name suggests, the PAVA can be different systems. So there can be a PA system in the building and a voice alarm, and the first one is doing only the communication, usual, say the general communication stuff, and the second is only activated during emergency. But nowadays, the industry standard is that the PA and VA are glued together in one as PAVA, and that means that the majority of the PAVA of the voice alarm market is suitable also for the public address purposes, and such is the products of the Ambient system. Our voice alarm systems are quite sophisticated, and they can deliver multiple PA functionalities, digital signal processing. They have many different settings that you can flexibly optimize the sound system in the building in a very effective way, so that you don't waste resources on the unnecessary parts of the installation, such as too many speakers or high power in the amplifier rack. We can optimize the levels. We can adjust everything in a digital way on the touch screen or by a PC, and software for configuring the system. The products of Ambient are fully certified. We are maintaining the software, that we are supporting the software constantly. Our software updates come regularly in a regular way to our end users. So we are improving our functionalities, and Ambient is also not only the manufacturer, but we give our customers the highest standard support in terms of designing, commissioning of the system in the building, and later support, maintenance. We deliver the full package, not only the box with the product, but also advice, expertise, acoustic simulations, calculations, estimations, and technical support before, during, and after the installation of the voice alarm system. So, Ambient is the full package company, and we are also the original manufacturer of the equipment, which means that we know our product very well from scratch, and we can give you the best possible support in maintaining your voice alarm installation. Yes, I think I made it a little longer than we expected, but I guess this doesn't harm too much. Thank you, everybody, for your attention. I hope my speech was clear and useful. If you have any questions at this point, please join in and speak up. If there's anybody who has a specific question, I would be very, very happy to listen to it right now, if we have time for it. I do have time. Please let me know if anybody would like to ask any question. You can also let me know on the chat if someone has a question. Please let me know. Okay, I guess there are no questions. I guess there's no questions. Yes, I'd like to thank you very much for your time. Appreciate very much your attendance and attention. If we can be of any help, me or Sebastian, here at Ambient, we are very happy to help you. Oh, yes. Vadims asks, are there any special fire alarm system requirements needed to be connected to ambient system equipment? Well, no special requirements. If the fire alarm system that we speak about is EN54 compliant, has the EN54-2 certificate, yes, then it is compliant with the ambient system. It is basically the interface between the voice alarm system and fire alarm system. Most of the time is still the contact interface. Yes, so we have discrete inputs, outputs that are connecting fire alarm system output side with the input side of the voice alarm. And that means that when we have the EN54 compliant fire alarm, then we can be 100% sure that the ambient system will cooperate. There are no special requirements. There are some questions. Alexander has asked questions before that I missed, I'm sorry, on the chat. Good. What is the maximum distance of the speaker line? That is a very good question, because the answer is, it depends. The maximum distance of the speaker line depends on how many speakers you have on that line. That has to do also with the kind of cable you are using. If you are using a cable gauge of, for example, 1 square millimeter, you can make a shorter line compared to the 2.5 square millimeter. Yes, so it depends on how many speakers you have, what is the load on the line, and what kind of cable you use. And I could say roughly the usual, you don't have to worry about the length of the line up to the length of 300 meters, I would say, 200 meters, 300 meters. And I'm saying that from 2 to 300 meters because it depends on the total power, and it depends on the gauge of the speaker cable and the distance between speakers. But on average, 200 meters is not a problem. And in the most demanding, if you have a very small load on the speaker line and a good cable, you could even run 800, 1000 meter with a good cable and a small amount of speakers. Another question, 16 AB zones. Yes, 16 AB is I don't understand this question. 16 AB zones. I guess this is what does it mean? The 16 AB. This means that we have 16 zones. Each zone has A line and B line. That makes 32 lines, and these 32 lines are making in the AB setup 16 maximum 16 zones. Another question: is yellow for free? No, yellow is not for free, we sell, but we have a lot of different licensing schemes. So you can buy a small license for small amount of components that you can control on the screen, or if you have very big installation with multiple control points, for example, many zones and many messages to be delivered at the same time, then you can expand your license and buy a more expensive license. But there are also cheaper licenses for more simple systems. Next question is from Alexander's. If there are more zones than control inputs, it means that some zones will not be monitored. Well, normally speaking, you need to be able to trigger every zone separately. So normally when you design your system, you adjust if you have a number of zones required, you usually need to define number of inputs accordingly, so that every zone can be triggered with a separate input from the fire detection system. And with multi-VES, I will show you. I can show you quickly. With multi-VES, this is the control unit of multi-VES, if you remember. And this is the backplane of the multi-VES control unit. And here you have slots, and there are some inputs already built inside. There are 2 inputs already in. And if you need more inputs, you just add the control input card, this one with 8 inputs. And if you need more zones to be controlled, then you can simply add another card to add control inputs, and then all these inputs are monitored. Yes? Okay. Next question. Okay, these are all the questions I've seen so far. Maximum distance, 16 AB zones, yellow, number of inputs, special fire alarm requirements. Yes, that's it. Thank you very much. Thank you, appreciate it. I hope it was not boring. I'm sure that some of you guys have already some experience with low voltage installations and fire detection, obviously. I have the idea that most of you have not done the voice alarm so far, so I hope the information I was giving to you was not too basic, that it was indeed informative. And I thank you very much for your attention. And if you feel like it, you can always contact your partner in your country. That we have our partner dealership in Latvia. And in case of any questions or any help needed, we can always organize another meeting on a specific topic, and we can make a more detailed training if you need. Thank you very much. Thank all of you for your time. Everyone has made it to the end, and I hope you can have some thoughts about the voice alarm systems. The trend in many countries, within the EU, the voice alarm systems are pretty much standard in many countries, but in some countries it is still on the beginning. Let's say the requirements for voice alarm. So there's still a lot of work to do in the voice alarm areas, and I think it's very important very important installation in the buildings where special care has to be taken about the evacuation, because it's proven that it saves more lives in a shorter time. And I think the voice alarm system is the way to go in terms of the fire security and other disaster management, to save people's lives and to save assets. Thank you all, and have a good day.